Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Last episode we managed to lay some bricks and build bridges, so today we will add another dynamic element to the levels, the elevators. Now elevators are capable of pushing Duke to new heights while the activation key is pressed, and when Duke exits the elevator it should retract down to its starting position. This will be the first time Duke will be pushed around by something else than just the keyboard, so that'll be a nice little added challenge for us. Alright, let's put on some elevator music. So here we are at our trusty DOS game modding wiki at the Duke 1 level format page to figure out the correct tile for our elevator. And as you can see here, the active tile list says that the tile code for the elevator is 3001 hexadecimal, and the tile index for the associated graphic located in the object tile map is number 5. So first order of business is to just start adding a new class to represent our elevator. And we'll make it extend the active tile as usual. So let's create a matching constructor. And let's have a render function that draws the tile from the objects list number 5. And what else do we need? We need to override the update method to fix the elevator in its place. Now in the active factory we can add it here. We said it was 3001, new elevator. And in the resource loader, because we have the active tile mapping here, and then by default after an active is created, we're copying over the left tile by default, and for the elevator we want to retain the original tile. So I don't really like this, so I will change this in a future episode, but for now let's focus on the elevators. Okay, so I think this should add the elevator to our game as at least a graphic. There's no behavior just yet, so it won't do anything. And as you can see, there it is. We can walk straight through it. So first order of business is to make it solid. So let's go to the level class where we have our solid Boolean check here. And what we will just do is we will just add an extra case here for our elevator. So this will make the elevator solid. So to confirm, we'll just run over there. And because now the tile is solid, we can start using it as a means of going up. All right, yeah, so we can stand on top of it and bump into it. So that's looking pretty good. Okay, so now in order to go up, we need to stand on top of it and press an up key. So the standing on top is something we already done here in the bridge class. We made a method that says like, hey, is Duke on top? So I think what we'll do is we'll promote this to the superclass here so that we can use it for other active tiles as well. So let's go to our collides with stuff here and let's just add a public boolean and let's flip it around. So let's say if this tile is on top of some other active tile, and if we are on top, that means that the x comparisons should be pretty much the same. So if our x should be greater than or equal to the active x, and our x plus our width should be less than or equal to the active x plus the width of the active. And here comes the thing we need to really look closely. So our y position plus our height plus 1 should be exactly equal to the active's y. All right, and then let's go back to the bridge and let's say if Duke is on top of this. I think this makes slightly more sense in terms of reading it. All right, so that should have the bridge sorted. And then here in our update, we can say like, okay, so let's keep track of Duke here, Duke. And then here we can say if Duke is on top of this and he's interacting. But I mean, or pressing the use key or whatever, but we have not implemented that just yet, so let's skip that. Then the elevator should go up. So I guess we'll make a go up method, and if Duke is not on top, then Duke can go down. Yeah, so let's make those two methods, private void go up, and I guess we need a game state here, and a go down. So let's pass in state and the state. All right, so in order to go up, what we need to do is grab Duke again. We need the level. We need the column that our elevator is in. Because what we're going to be doing is we're going to check above Duke if the tile above Duke is free, and then if it is free, then we will push Duke up one tile and then fill in the tile beneath that with a solid tile. So it appears that Duke will move up and stay up and not fall down again. So if the level is not solid for the row, so let's calculate a row. So we said that we are interested in Duke's row. So Duke's y divided by the tile size. So this is the top row for the Duke entity, but we need to subtract 1 because we're interested in the row above it. So if that cell is not solid, then we should push up. So what we'll do is we'll say level set tile, and then we want the tile that Duke is standing on to be solid. And we'll just use the same elevator tile ID because we just made that one solid in the level class. So let's subtract y so that it will go up. And let's push Duke to that position. So let's say Duke get x, Duke get y, and then minus tile size because we want to go up an entire. Alright, so I think this should push Duke up when he's standing on top of the elevator. So let's see if that happens. Yep. Okay, the elevator doesn't go down again, and we've been filling up this column here with solid tiles that we're not rendering, but we cannot pass through the shaft of the elevator. So that's pretty good, so let's make it go down again. Now in order to know the original position, we need to keep track of the elevation of the elevator. So let's keep a track of an integer elevation, and let's initialize it to 0. And then here, let's just increment it, and then in the go down, we can just say like, okay, if the elevation is larger than 0, then we should push it down one cell and basically do reverse what we did here. So level is state get level, and then let's calculate a row. So that's the current row that the elevator is occupying, current column that the elevator is occupying. And all we got to do is set a tile. So row, column, and the tile ID that we are interested in is the tile above, directly above this elevator tile, because Duke is standing there, so that's guaranteed to be a non-solid tile. So let's get tile row -1 call. So this should make the tile non-solid again, decrement the elevation, and let's increment our y position so that we still have a functioning on top method. Okay, so this should retract the elevator. All right. Yeah, it's back down again. Going up, falling, going up. All right, and here we see a small bug. Looks like Duke is standing still, but the camera is just jumping around. And I think what the problem is that the camera centers around Duke, or tries to center around Duke, but he probably does try to do that a bit too. I mean, there's probably a problem with the centering code. So let's go to the graphics part, and let's figure out where we move our camera. And let's see, we have Duke, and then we calculate some screen X and Y variables, move the camera around. But I guess here is the problem. We increment the camera Y position with tile size multipliers. So if the centering requires less than a tile size, then it will center the camera forever because it will overshoot the target Y position. So I think what we need to do is just calculate the distance here, screen Y minus the vertical center. And let's decide a multiplier. Multiplier is, so if the absolute distance is less than a tile size, then the multiplier should be the absolute distance. And otherwise, it should be tile size. And then here we can say multiply by the multiplier. And this can be a math.min, of course. All right, so the multiplier is going to be 16 if it needs to move bigger chunks, and if it needs to move less, then it's going to be a smaller multiplier. Okay, so now let's see when we fall down. Yeah, so now the camera centers properly. All right, so that's almost the elevator. There are two more things that we have to do. Is we have to introduce the key that uses the elevator, because right now the elevator just goes up when we stand on top of it, but we should be using the up key, the up arrow, and we should draw in the bottom part of the elevator. Right now it's just a floating tile, but we need to draw in this stuff here. So let's start with the draw code here to just render the bottom part of the elevator. And for that, we will start at the bottom. So let's create a new y coordinate. I guess we'll call it world y equals y plus the elevation times the tile size. So this will be the bottom. And then we have world y as long as it's greater than or equal to y. And then let's draw strips of 2 pixels at a time. And then we'll just draw the entire tile at world y. So this will just draw the bottom 2 pixels of each tile until we reach the top. And that should give us the gray underside of the elevator. Yep. All right. So that's looking pretty good. Then finally, let's add in our key. So let's go to the key handler. So we used to have the up boolean, but I'll remove it and I'll introduce a using boolean. And just, yeah, put it down here. Using is pressed. Don't need up anymore. And here we can say if is using, I mean. Then let's go into the Duke Nukem class where we handle our input. And then let's say Duke.setUsing key handler is using. Let's create this method. And yeah, we can just put it at the bottom here. So we can say this.using equals using. And let's add the field. Perfect. And then let's create a getter for it. Then we can go to our elevator and add an extra if statement that we already have here. So if Duke is using, then we should go up. All right. So nothing happens when we just stand on top of the elevator. But when I push up, the elevator goes up. All right. So yeah, I think that is a nice way to implement this elevator. Just putting in solid bricks, solid tiles beneath Duke, putting Duke to the next position. And that way, yeah, we can just go up, up and away. So I think, we'll take a quick look at the bridge. Since we've changed the on top code, we should verify if our bridge is still functional. So let's see if we can find the bridge. Yeah, it still works. So that's pretty cool. All right, so I think that'll conclude that for today's episode. We've had a couple of long episodes before here, so I'm okay with leaving this one a bit shorter. So yeah, I want to thank you very much for joining me. Next episode, we will add yet another dynamic level element. We will be implementing the doors that will block Duke's movement. And of course, we need to unlock these doors with a key, and that needs to be put in the correct lock. So yeah, hopefully you can join me for that one. For now, I want to thank you very much for joining me. If you have any questions, then feel free to put them down in the comments below. And if you like this series, then hopefully you can drop a like and a subscribe. All right, see you guys in the next episode. Bye-bye.